We'll say, hey, that's right, we're about this going. We're going to look at, today, we're going to look at designing a popcorn box using our polynomials to be able, and understand that we have here, to be able to maximize the volume for that particular popcorn box. So we're going to start with a set amount of material. The popcorn box that we're going to design is going to be rectangular, and it's going to be open topped, just like the popcorn boxes at your favorite local movie theater. Yeah, that's right. And so we're going to here's the design that we're going to do. What we're going to take is a two-dimensional sheet of material, and we're going to design it in a way that we cut squares, congruent squares. That means all the sides are going to be exactly the same off those corners, so that when we cut these out, we'll then be able to, on these lines, fold that up, thus creating a five-sided rectangular prism with the lid off, and we can put popcorn in there. Well, how much do we cut off? How much should we cut off those corners, off the corners here that we have, so that when we fold and fold and fold and fold, that it'll hold the most popcorn that it can hold. How do we know how much to cut that off? Well, the mathematics, the parabola, the algebra is going to help us determine that. And it happens to be polynomial in nature, the function that we're going to be writing. So we're going to talk about the volume. The volume, as the height changes, is what we want to maximize. So when we cut something off, whatever that square is that we cut off in the corner, when we fold that up, that's going to be the height of our box. Now visualize that. We're going to fold this up. That's going to be a side. That's how high the box is going to be that we're going to put popcorn into. So that volume we want to be able to maximize. Well, the polynomial function is written from the geometry class that we learned. Yeah, that volume of a prism is found by taking the length times the width times the height. And so if we know this material starts with, let's say, 28 centimeters of length, and the width of this starts with 21.6 centimeters of width, when we cut these corners off, we're changing that width and length for our box that we create. Well, so if all these are the same, how much are we cutting off of the, let's say, this side? Started out 28, how much are we cutting off for that length? How's that length changing? That's right, we're going to take that 28 and we're going to subtract away, or cut away, what? Not just 1h, but 2. So whatever that 28 was we started with, we're going to cut that length down to 28 minus 2 times the height. Hey, you know what? I'm going to interrupt because there's something really funky is coming up. I've got to stop here. I'll be right back.